welcome today. Today's lab you're going to be working on is we're going to be studying the properties of ionic versus molecular compounds. Specifically, you guys are going to be running some various tests. So we wanted to highlight one of the tests here on one of the properties that we notice is very unique to ionic compounds and very different from how molecular compounds. And it's the ability to conduct electricity. So if you come and take a look at our simple setup we have here, we have a standard little power supply here, completing a circuit to a light. And if we get a nice good connection, you see that our flow of electrons are able to transfer all the way through and give us our bright light. Now, the idea behind this property is it has to be in a dissolved state. So to illustrate that, we have some pure salt right here, our kosher salt. And we're going to show you that when we try to make that connection, here, notice nothing with the light. We're not getting anything going on. We're touching each side of the salt. The flow is not happening. So now we want to go to our three samples here to show that we've dissolved each one. First, we've taken a sample of like a spring water, more of like a distilled water in this case, really for us. So it's just pure water. And we can see, watch what happens with our light. We put our leads in. Notice we're not getting any kind of conductivity whatsoever. No lighting is showing up. Now there could be little transfers happening, but not enough to illuminate our light. So now we're going to go ahead and go to our next sample. Sugar, a molecular compound. One of the properties it has of it is it can break down to dissolve, similar to how salt does. It's allowing a lot of space between those molecules so we don't see the sugar anymore. Let's see now this property, does it have the ability to transport power through its medium for our light? Let's see. We put our two probes in, get them even kind of as close as we can together. And once again, we're not seeing really any kind of change with our light bulb there. Now we go to our last sample here. We've made up some salt water. So in the salt water here, we have these sodium ions, these chloride ions. They're now loose in solution. They allow the electrons from the battery here to flow through them. And we can see that with our light when we put in our probe. And now notice we're getting the passage of electricity. And we can further see when you look down into here, because we are using some direct current, we're actually breaking apart a little bit of the water molecules in there. We got a little electrolysis going on. That's why there's bubbles coming out of our red lead here. So there you go. This is just a highlight for you, the property of ionic versus molecular, meaning ionic compounds in solution conduct the flow of electrons. Molecular compounds typically do not.
All right, so the first procedure you're going to do in this lab involves figuring out the melting point of 4 different compounds. So here we have a set of 4 different compounds. We have 2A, 2B, 2C, and 2D. Now, if we can zoom in a little bit on the setup that we have here, in the lab you're going to cut out a piece of foil. We're going to have that ready for you. You're going to make 4 compartments. You notice that we have spaces for elements A, B, C, and D. And you'll also notice that they are very small amounts of virtually identical white powders. So, unless you're some sort of detective, you're not initially going to be able to figure out what these are, and you're certainly not going to be able to figure out which are ionic and which are molecular. And you'll also notice that we don't have a thermometer here, so we're not actually going to measure the melting points of these compounds. What we're going to do is we're going to look at this qualitatively. That is, we're going to turn on this heat source, this hot plate that we have here, and we're going to turn it on about halfway, which I have done. I'm turning it up to the 5 mark, and we are going to see, as this hot plate heats, which of these substances melts first. So, molecular compounds tend to have very low melting points, and so we would expect them to generally melt first. Ionic compounds tend to have very high melting points because ionic bonds are stronger than the covalent bonds that form molecular compounds. So what we're looking for here is not an absolute melting point. We're not going to collect any numbers here. We're just going to see which ones melt first. So if we can zoom in here, we're just going to watch this procedure as it unfolds, and we're going to see if we can detect which ones are melting.
Alright guys, here's part 2 of your lab. Come and take a look. For this you're going to need your Logger Pro program, which is a program you've seen us use before for our thermochemistry unit. So when you open Logger Pro, the program, and you plug in your conductivity meter, this is what should pop up. You're going to need to get both a GoLink piece and a probe, because this is what connects to your computer. All right, so the focus of this part of the lab is on 2 different properties. We come over here. The first is conductivity, which relates to the first video you saw, our little introduction with the light bulb. Conductivity is when electrons are allowed to flow through something. Solubility is our second property, which is the ability of a substance to dissolve. So if I were to take my probe here and put it in just some water, come on over to your screen in Logger Pro. Right at the bottom here, this is the current reading. So we're at 36. That's a baseline reading for just plain old water, and it's pretty low. So yes, we are getting a reading, but there's not much stuff in that water, and so that is considered a very low, basically negligible conductivity. All right, stop that run. Okay, so you guys have 4 different substances, the same 4 that you worked with for part 1, and we have those 4 things in what's called a well plate here. So this is what you're going to use to set up your samples. You'll see I have 4 different wells labeled A, B, C, and D. There's one labeled W because I'm going to do some with plain old water. If you flip your well plate over and write with Sharpie, you have to write your letters backwards, but then you'll be able to keep track of your samples, because labeling is key in this lab, guys. I can't say it enough. Labeling is key to success in this lab. All right, let's go and do it then. So following your lab instructions, once you have labeled your 4 different wells, I spread mine out just because you'll see it's a little bit difficult to get the probe to different wells if they're all super squished in together. So I spaced mine out. You're going to use a dropper. This is your plain water. I'm just going to fill that water well first. Okay, so the other thing you want to watch out for while you're doing this part is not to cross-contaminate things. So it's very, very important for you to, once you read a sample and collect your data, to take this probe and rinse it out over the sink. So for that, we have a water bottle here filled with distilled water. And you're gonna wanna rinse that off right over the sink. This part down here, that's where the reading is happening, okay, inside that piece. So you wanna get that nice and rinsed. That way you get a true reading of each of your samples. All right, so let's get our samples in here using our scopula. Little bit of A. You're not going to need a whole lot. Actually, the less you use, the better for this part. Okay. Sample A. guys, if you remember from the previous video, the intro video, sort of the key piece of conductivity is the substance has to be in the dissolved state. So while these are solids, we're going to add some water to each well. Carefully get those samples in there. Just a little bit. Okay. And dropper of water. All right, so you're gonna fill them just halfway up with some water. If you don't put your dropper in the fluid, then you can just keep on using that same dropper. Remember, cross-contamination is something you want to watch out for during this part of the lab. Okay, so I'm not actually putting the dropper into the water, just putting enough in there to get it to dissolve. And the less solid you add, the better in this case.
Now you can see that in B, in C, and in D, at least most of the solid has dissolved. But if we go back up to A, we notice that there are still big chunks of A left over, which suggests that that one does not dissolve in water. So that's a very important property to notice.
Okay, so this is your table, guys. This is on your lab. This is what you should be filling out for this section. Solubility is whether something is dissolving or not. Okay, electrolyte. So electrolytes, again, if something is an electrolyte, it's really good at conducting electricity. So we'll see a high reading on the electricity probe, or the conductivity meter. All right, let's get that reading. All right, guys, so I'm gonna get my probe in here, making sure that that metal part is actually touching the liquid. Okay, and our reading on Logger Pro for sample A here is, I'm gonna let it settle, I would say around 64. It's gonna fluctuate a little bit, but that is a close reading. All right, so again, before I go to the next sample, quick wash, make sure you don't cross-contaminate. Sample B. All right, so sample B is reading about 100, 99 to 100. Okay. Quick rinse. Okay, sample C. Whoa, okay, so see that difference, guys? That is a major jump up to about 31,300. Okay, and finally, last but not least, sample D. Right about 11,000. 11,200, say. All right, guys.